So our goal was to find r double prime, set that equal to negative gm over r squared ur, which is the acceleration of the planet toward the sun. This is one expression for the acceleration. This is another. We set them equal. We've gotten an expression for r double prime, worked through the details. Here's our expression. So we're going to simply copy that expression down and set that equal to the acceleration. Now, notice that we just have a ur on this side. We have a ur and a u theta term on this side. Now, u theta is perpendicular to ur, so that there can be no u theta term on, there's no u theta term on this side, there can't be one on this side. This doesn't have a component perpendicular to u sub r, so this side can't have a component perpendicular to u sub r. Therefore, this term must be 0, and of course u theta isn't 0. The only way this term is going to disappear is if this coefficient is 0. Now there are implications of this. Basically this ensures that our angular momentum remains constant, but we're not analyzing this in terms of the physics. We're going to analyze it in terms of mathematics. We'll see what that might mean, and we'll try to interpret that in a way that's intuitively plausible. But our equation then becomes just this term, and that d theta dt is squared, and this is equal to negative gm over r squared times u sub r. Now, what's this tell us? Well, it simply tells us if we multiply through by r squared and just set the two coefficients of ur equal to one another, so that we don't even need the ur in there anymore, we end up with r squared r double prime minus r cubed times d theta dt quantity squared equals negative gm. Now, what in the world are we going to do with this? Well, we'll take a look at this in a minute.